In this next section, I'd like to cover what technologies comprise a network from a very high level. What's going on behind the scenes in a network? Because as you pursue more and more of these options of computer networking careers, you're going to see these terms come up quite a bit. And you're going to need to know what they consist of. So the technologies I'm going to overview are routing and switching, data center, collaboration, and security. So I'm going to go ahead and make this full screen here so we can see. Let's start with this idea of routing and switching. What is that? So first of all, think about the concept of routing. Take computer networking out of it for a moment. If I think about the post office and I say, well, my packages are being routed through the post office. Or if I think about the airlines, how the airlines route a plane from one destination to another. What are they talking about? They're talking about some sort of system where there are multiple ways to get from point A to point B. And routing is picking the best way to get from point A to point B. So that's what routing is. So let's look at routing and switching from a network perspective. So let's say here I start with some PCs or some laptops. They all have network interface cards which terminate in a switch. Okay, so there I have a very small local area network. 3 laptops or PCs connected to a switch. Switching is how exactly is this box, this switch, taking the electrical data from one PC and forwarding it to another PC. For example, when data comes in this way from PC A, if that data is destined to PC C, switching is all about how does that happen? How do we get that data in this network interface card and out this network interface card without bothering this guy in the middle, since the data is not for him? That's what switching is all about, creating our local area network. So a local area network is created out of this concept of switching. Now maybe I've got another local area network. They're connected to their own switch. I got another one down here. They're connected to a switch. And then lastly, a 4th department. Now I could connect these switches just together with cables, but I have a little bit more requirement than that. So let's just say that this is department number 1, department 2, department 3, and department 4. So I start thinking, well, if I just connect all these switches together, all 4 departments will be able to exchange data, but I lose some control. For example, maybe I want to impose some restrictions that departments 3 and 4 can't exchange everything. There's only certain types of data I want them to be able to exchange. Other types of data I don't want them to be able to exchange. And maybe I don't want departments 3 and 2 being able to talk to each other at all. Well, this is where using something called a router would come into play. So I have a router here, and I connect my router to my various switches. And now we can see all the information is going to have to pass through one of the 4 connections on this router. And the router gives me the ability to segment this network, have a little bit more control over where the data is going to go, who can see what, as well as a variety of other things. Okay, so there's a basic network. So switching was getting the information through the switch. Another aspect of switching is like this. Maybe I do have a bunch of switches that are connected together, maybe in like a triangle like this. Let's have these be my users here. My laptops and PCs connected to these switches. Another aspect of switching is how is the data going to go through these switches? What's the path it's going to take? And what's going to prevent data from possibly just looping around between these switches forever and not ever making it to the destination at all? That's another component of switching. So switching is utilizing switches and controlling the flow of data through switches. and making sure it only goes where it's absolutely necessary to go. Routing, I've drawn one example of a router. So this is a basic example of routing where I just have a single router, and I'm basically just using it for security reasons, to be able to define what parts of the network can talk to other parts of the network. But there are other reasons for routers as well. For example, let's say I have a network here, and I'm going to draw a whole bunch of, so let's say this is, each of these boxes represents a portion of my network. Okay. Okay, so let's put some more boxes in here. Maybe one box represents my human resources department and all the hosts and switches in that department. Another box represents payroll. Another box represents marketing and engineering. So all these red circles represent routers. Router 1, router 2, and so forth. And the blue lines that are coming out of the routers represent cables. They're connecting back into switches. So I'm not going to draw all my switches, but there would be a switch there, there might be a switch in here, and so on and so forth. Now, I'm going to need to connect these routers together so that all my departments can talk to each other. So let's say my router connections are like this. So you can see now there's a lot of redundancy in my network. In other words, what I mean by redundancy is if the connection between router 1 and router 2 fails, router 1 can receive data from, let's say, payroll, and it can still get that data to human resources by taking a different path. So redundancy means there's lots of different paths I can take to get to my destination. Just like when you're sending a letter through the post office, or you're taking a flight getting from New York to Dallas, Texas. Lots of different ways you can get there. So another portion of routing is determining the best path. These routers run specific languages, specific protocols to figure out what is the best path to get from point A to point B. So if someone's trying to get from payroll to human resources, most likely this router will choose this path back and forth. However, if someone's trying to get from payroll to marketing, which is over here, well, it might be a completely different path. It might go down here, across, up here, and then down and across. So routing is the intelligence to figure out how to get data in the best path possible from one section of the network to another. So that's routing and switching. Okay, what's this term called data center? Well, let's say, once again, I mentioned in the previous video that all of our hosts, our laptops, our PCs, our smartphones, most likely are connecting to the network for the purpose of connecting to a server. And if we have a whole bunch of servers, those servers are usually stored somewhere in a data center. So let's say each one of these rectangles here represents a server. And we've got stacks and stacks of servers. One server might be hosting all of our websites on our corporate intranet. So our corporate websites, like our employee website, our payroll website, our marketing website. Another server might be in charge of our email. Maybe another server is our payroll server, dedicated just for payroll, for all their spreadsheets and their paycheck information, everything like that. And all that stuff is stored in a very secure facility called a data center. So one aspect of networking is called data center networking, which is, all right, what's the most efficient way to connect these servers to the network? How do we make sure they're very reliable and redundant, where if one connection to a server fails, it has a backup connection? What are the technologies to make sure these connections are the fastest possible? Maybe a regular Ethernet connection is not good enough and we need something else. Maybe we need specialized network hardware and software to really connect everything here together to give us the most security and redundancy possible. So because in a data center, we're talking about massive computing resources. We have lots and lots of data that has to be accessed very, very quickly. The requests are coming from all sorts of parts of the network, and this has to be very, very reliable. We can't have anything go down here. Because of that, the networking technologies that we use in the data center and to connect the data center to the rest of the network are different than usually the technologies we use just to connect our hosts together. So we would call those data center technologies. Another type of layer of complexity that you could add onto the network is called collaboration. And I'll just verbally describe that. So most companies these days, the exact same network that I've drawn here that's being used to pass their data, to have their emails flowing across, to have their websites flowing across, they want those same cables, those same resources, those same routers and switches to also be used to carry their audio traffic, their telephony traffic. So when you pick up a phone in most networks today in companies, when you pick up your phone and you talk into it, that phone is converting your voice, your speech, into the same type of electrical signals that's carrying your data. So the electrical signals are carrying your websites, your emails, your file transfers. Right in front of or behind those electrical signals are other electrical signals. They're carrying your telephony, your voice traffic. So collaboration, when we talk about networking collaboration is this idea of how do I use this existing network that's my routers and switches are carrying my user data to also use it to carry my voice and my video as well. If I want video on the network, how do I do that? How do I connect my digital video cameras to the network? My video servers are storing my video files. How do I connect those to the network? How do I optimize the network so that video traffic doesn't completely hog up and use up all of the network resources so there is no resources left for my data traffic? How do I optimize the traffic so that when I connect my telephones to the network, that when someone picks it up, the voice is nice and crystal clear, it's not choppy, it's not having problems. So that's what we mean by collaboration. Collaboration is, in addition to your user data, how you layer or add your voice and video traffic on top of your existing data network. So all the technologies involved in that falls under this umbrella of collaboration. And then, of course, another form of network technology is security, right? So how do I ensure that somebody doesn't walk into my company who's not an employee? And how do I prevent them from connecting to the network with their laptop? And now they have access to my network infrastructure and they can get to my network resources. They can get to my own internal websites, my own internal spreadsheets. How do I make sure that when people connect to the network, they are authorized users only? How do I make sure that when data is passing through the network, only certain data is allowed on certain cables? Only certain data is allowed through certain sections of the network, and other parts of the network block certain parts of data. How do I do that? That falls into the security realm. If someone is doing an attack on my network, if they're trying to use my network to carry data to a server because they want to bring that server down, they want to make it crash, they want to make it fail, how do I detect that type of an attack? How could I have features in my network that stop or prevent that type of attack from being successful? That all falls into the realm of network security as well. And there's different types of hardware and different types of software that you can layer onto your network that give you the ability to control it from a secure perspective. So that concludes this video. In this video, I've talked about these technologies of routing and switching. Hopefully you now have a better idea of what's meant by those terms, as well as data center, collaboration, and security. So in the next video, I'm going to start talking a little bit more about some computer networking job roles. What are titles that you would typically see, and what do those jobs do, and what do employers typically expect of people who are applying for those types of jobs?